As Earth's closest neighbor in space, we know a lot about the Moon. We know that the Moon is less than a third of the size of Earth. We know that every 27 days, the Moon rotates around Earth and spins at the same time. This means that the same portion of the Moon is always facing Earth, and the side that isn't is often referred to as the dark side of the Moon. The Moon also plays a huge role in the formation of tides on Earth. It drives Earth's tides primarily through its gravitational pull, which attracts the ocean water and causes it to bulge outward, creating high tides on the side facing the Moon and due to centrifugal forces on the opposite side. As Earth rotates, coastal areas pass through these bulges daily, resulting in 2 high and 2 low tides roughly every 24 hours. It is believed that the Moon formed after an impact that the Earth had with a protoplanet early on in the life of the solar system. Such an intense and energetic collision is mind-boggling, and it's really amazing that we have a direct result of that collision just floating around in the sky. The Moon, therefore, is a great tool for understanding Earth's history. Studying it uncovers Earth's hidden history, offering a preserved record of events long erased from our planet. For example, studying the South Pole Aitken Basin, the oldest and largest crater on the Moon, tells us a history of long ago that's largely been wiped out here on Earth because of water and erosion. We can learn from the impact history of the Moon, which tells us a lot about a time called the Late Heavy Bombardment, a period of continuous asteroid bombardment that helped shape what the solar system would become 4 billion years ago. Although, in recent years, this theory has been called into question, according to NASA. We can look at craters that would long have eroded from Earth to identify the chronological history of the Earth. One such crater is Shorty Crater. Shorty Crater is a 110-meter-wide impact crater in the Moon's Taurus Littrow Valley. The crater, which is about 14 meters deep, was visited by NASA astronauts during the Apollo 17 mission in 1972. Scientists had targeted the crater as a place worth visiting because existing orbital images at the time had shown that the crater was surrounded by a dark field of ejecta. Since the surrounding areas seemed to be blanketed by pyroclastic materials, the dark ejecta around Shorty Crater led scientists to speculate that perhaps this crater was a volcanic vent and not an impact scar, even though impact remained the preferred interpretation. On December 11th, 1972, Apollo 17 successfully landed in the middle of this amazing valley. The landing site was surrounded by low mountains with steep cliffs that exposed ancient rocks from inside the lunar surface. The mission goals included sampling rocks and soil that might reveal the age of the distant Tycho crater forming impact, sampling ancient highland material that might reveal the ages of 2 mighty basins, return more variety of basalt, collect dark pyroclastic material, and see if Shorty Crater was indeed a volcanic vent. The astronauts Eugene Cernan and Harrison Schmitt spent 3 days performing a reconnaissance exploration of part of Taurus Littrow Valley. On the second day, they drove a lunar roving vehicle to the edge of Nansen Crater at the foot of South Massif, a 2,200-meter high mountain. On the way back to the lunar roving vehicle, they headed north across Lee Linkenskarp, a thrust fault, and onto Shorty Crater. It was at the edge of Shorty Crater where Schmitt first noticed interesting orange soil underfoot. At the moment, it seemed that the crew had indeed discovered oxidized rock, a sure sign of fumarolic volcanic vent. Schmitt then dug across the crater rim to get samples of the orange soil and black soil beneath it. Being orange rather than gray, the debris was slightly lighter than the surrounding surface debris. At first, Schmitt, who was also a professional geologist, thought the orange material was volcanic ash, but he was troubled by the rim's rocky breccia, which is a characteristic of impact craters. Schmitt was doubly right. As it turns out, the orange soil was not oxidized vent material, but something equally exciting, titanium-rich pyroclastic glass. When a Shorty impact event occurred millions of years ago, the pyroclastic glass was excavated from about 10 meters below the surface and thrown out onto the rim. The orange glass was deposited some 3.5 billion years ago. Then shortly after it was deposited, a thin layer of basalt flooded this portion of the valley and formed a protective cap. Then, not too long ago, the orange glass was brought to the surface by the impact that formed Shorty, and the Apollo 17 crew arrived. Eventually, the Shorty crater deposits will get churned back into the surrounding landscape by small impacts. Luckily, Schmidt and Cernan came by at just the right geologic time. These findings showed that the idea that the valley had witnessed very large lava eruptions was correct. Imagine lava being erupted so fast that it shot up many hundreds of meters and splashed over the terrain for many tens of kilometers. The lava were shot up so high because there were large amounts of gases in the magma that rapidly exsolved as it neared the surface. A process similar to what you experience after shaking a soda can and opening it up. Scientists were able to find little remnants of volatiles on the glass beads, both orange and black, including zinc and sulfur. From the extent of the deposit and its composition, it was clear that these materials came from deep sources within the moon's mantle. So by simply walking to the edge of this small, seemingly insignificant crater, the crew were able to sample and bring back incredibly valuable samples of the deep moon. In total, Apollo 17 was able to return 741 individual rock and soil samples totaling 110 kilograms, the largest sample return of any moon mission. These samples would help our current understanding about the moon's volcanic history and the formation of the early solar system. The next day, Cernan and Schmidt drove north and then east to sample the North Massif and the Sculptured Hills. Both destinations were older than the Mare Serenitatis, a 419 miles wide lunar mare. They represented two different ancient crustal samples. From these rocks, scientists were able to determine absolute age dates for the formation of an ancient basin. All in all, Apollo 17 was a huge success for both science and engineering. NASA's next mission to Moon, Artemis 2, is currently scheduled to launch no earlier than April 1st, 2026. This crewed mission will send 4 astronauts on a 10-day flight around the moon and back to Earth. The astronauts will explore more of the moon for scientific discovery, verify modern human capabilities in deep space, test systems for future lunar landings, and to build on the foundation for the first crewed missions to Mars.